Next, we're going to talk about subsets. Set A is a subset of set B, expressed as this notation, kind of like a C on its side with a line underneath it, if every element in set A is also in set B. Make sure that you understand we're talking about comparing a set to a set, not an element to a set. We're talking about a set to another set. The notation, the C on its side with a line underneath and a slash through it, means that set A is not a subset of set B. So there is at least one element in set A that is not an element of set B. So let's do some examples. Here I have the set of -3, 0, and 3. Is that a subset of -3, -1, 1, and 3? Now, first of all, we are talking about a set comparing to another set, so that's the correct notation. -3, I have a -3 in both the sets. 0, I do not have a 0 in the set to the right, so this is not a subset. The set of -3, 0, and 3 is not a subset of the set of -3, -1, 1, and 3. Next, we have the set of Monday, Friday. Is that a subset of the set of Saturday, Sunday, Monday, Tuesday, Wednesday? Well, again, no, because Friday is in the first set, but it is not also in the second set. The next example, we have the set of all the letters in the word conversation, and is that a subset of our next set? So we just have to go through each one of the letters. Let's start with C. Is C found in the set to the right? It is. How about O? Is O found in the set to the right? It is. N, yep. V, yeah, I see that in there. E, R, yes. S is there. A is there. T is there. I is there. O and N. All of the letters in the first set are also in the second set, which means it is a subset. Okay. Now every letter didn't have to be there, but every letter in the word conversation needed to be at least present in the set to the right. Let's do another one. We have the set of -3, 3. Is that a subset of the set of -3, -1, 1, and 3? Well, let's see. -3, yep, that's over here. 3, yep, that's over there. So all of the elements in the first set are found in the elements of the second set. So therefore, the first set is a subset of the second set. What if it's the exact same set? -3, -1, 1, and 3. Is that a subset of itself? -3, -1, 1, and 3. It sure is. Every single element in the set to the left is also found in the set to the right. So therefore, this means that every set is a subset of itself. We can write that A is a subset of A for any set A. All right, how about this next one? Let's say A is a set of all X, such that X is a letter in the word roof, and B is the set of all Y, such that Y is the letter in the word proof. So in set A, we have the letters R, O, and F. In the set B, we have the letters P, R, O, and F. So is A a subset of B? Let's see. R, that's covered. O and O, that's covered. F, yep. So all of the letters in roof are found in the letters of proof. So therefore, A truly is a subset of B. Now, is B a subset of A? No. P is not found in the word roof. So therefore, B is not a subset of A. So the order there really matters. Next, let's discuss proper subset. Set A is said to be a proper subset of set B, expressed as just the C on its side, right? Kind of like a U on its side there. If A is a subset of C, and if A is not equal to B. So we already said that A is a subset of itself, right? But A is not going to be a proper subset of itself, because it can't be equal. So let's see. We have set A is the set of 2, 4, 6, and 8, and the set of B is 2, 8, 4, 6, and 10. So A has to be found in all of B, so 2 and 2, 4 is found in 4, 6, yep, 8 is found in 8, yes, so that works. So what that tells us is that A truly is a subset of B, and additionally, A is a proper subset. And the reason it's a proper subset is because A is not equal to B. So not only is it a subset, but it's a proper subset. All right, let's take a look at our next example. A is the set of all X such that X is a person and X lives in Atlanta. The set B is the set of all X such that X is a person and X lives in Georgia. So we know that if you live in the city of Atlanta, Atlanta is found in the state of Georgia. So if anyone lives in Atlanta, they also must live in Georgia. Therefore, A is a subset of B. And additionally, because there are people that live in Georgia that don't live in Atlanta, A is not equal to B. And therefore, A is a proper subset of B. The next one, we have the set of 0, 2, 4, 6, and 8. And we're comparing that to the set of 8, 0, 6, 2, and 4. So we have 0 is in both, 2 is in both, 4, yep, that's in both, 6 is in both, and then 8 is in both. Okay, so is the first set a subset of the second set? Sure it is. It is a subset. Is it a proper subset? No. In this case, because the two sets are equal, we know that this is not a proper subset. So we're going to put a slash through the proper subset notation. All right, how about our next one? The set of all X such that X is a man compared with the set of all X such that X is a person. Are all men persons? Yeah, all men are persons. So therefore, there is everything that is in the set of the left must also then be the set of the right. Is there any man that is not a person? Well, I am. I'm not a man, but I am a person. So because I'm a female, I'm a counterexample. And so because I'm a counterexample, we know that these sets are not equal. There are more persons than there are men. So therefore, we can also say that this is a proper subset. Next, we have the empty set. Okay, is the empty set a subset of the set of 8, 0, 6, 2, and 4? Sure it is. There's nothing in the empty set, and therefore everything that's in the empty set is also in the set of 8, 0, 6, 4, and 2. So it is a subset. And additionally, we know it's a proper subset. And we know it's a proper subset because it's not equal. All right, the empty set to itself. Is the empty set a subset of itself? Sure it is. Every element that's in the empty set, which is nothing, is also in the empty set, which has nothing. So therefore, this is a subset. But it is not a proper subset because the empty set is equal to the empty set, so therefore it can't be proper. Okay? The way I remember subsets and proper subsets is I think about less than and less than or equal to. Less than or equal to could be, we could have less than, or we could be equal to it. That's kind of the same thing as subset. Subset could be equal, right? These two could be equal. Do they have to be equal? No, they don't have to. Whereas less than, strictly less than, and proper subsets, both of these can't be equal. And the symbols kind of look the same, right? Less than and less than are equal to, proper subset and just regular subset. So that's just kind of how I remember that.